Hi everyone and welcome to another video. In this video I want to talk about how to use Makefiles to build projects. Make has been used historically often to build C projects, but you can build any type of project with Make, or you can even build things that are not source code. In this video we'll cover the basics of Make, but there's so much more to learn that won't be covered in this video. Let's get started. Alright, I've opened up an empty directory with some standard C code. There's really not much here, but let me just look through it. I have a main file called app.c, and what this will do is it'll basically create two pair C objects, perform some operations on them, and print out a new pair. There's some helper files in calculator and utils. So the calculator includes some functions for adding, multiplying, and subtracting, and utils includes just a function that prints out a pair to standard input. So really there's not much code here. It's not too important to understand C code or how it works. I will be using this just as an example so that we can have something to build using Make. Alright, let me get out of this. To start using Make, you need to define a Makefile. So let's create a new file called Makefile with capital M. And in this file, we can define what we want Make to do. Now the main objects in Make are called rules. Rules tell Make what to do, how to do it, and when to do it. So let's go through how that works. I'll start by defining a simple rule called hello, and I'll say echo hello. Now what this does is it says there's a new target. The first word of the rule is called the target, and the target is named hello. The part indented from the target, and note this is indented by a tab, not spaces, is the recipe for the rule. The recipe says what to do when you want to build this rule. In this case, we just print out echo hello. So I can save this and quit. If I run make hello, this tells Make to build the target called hello. So if I do that, you'll see that it prints out echo hello and then hello. Now this seems kind of silly that it prints out echo hello and then prints out hello itself. But this is a normal and intended function of Make. Now when you just print out hello, it doesn't really make sense to print out that you're going to echo hello and then actually echo it. So what we can do is we can prefix the command with an @ symbol, and this tells Make, hey, when you run this command, don't print out that you're running the command, just run the command and print out the output. If I save this and quit, and I type make hello again, you'll see that it just prints out hello. It doesn't print echo hello. Now you'll notice if I just run make, it just prints out hello. This is because Make has something called a default target, which is built whenever you run Make without any arguments. The first target you define in your Make file serves as the default target, but there are ways to override which target is the default. Typically the targets you define in a Make file are files that you actually want Make to create. For example, you might want Make to create an executable, and then you would define a target with the name of the executable as the target name, and then define a rule saying how to build the target. Let's see how this comes into play with this simple hello example. If I create a file called hello, and then I run make hello, you'll see that instead of printing out hello, Make says that hello is up to date. This is because Make expects each target to produce a file with the name of the target. In this case, we have the target called hello, and so Make looks in your directory and says, oh, there's a file called hello already. I don't need to do anything to build the hello file. Therefore, Make just says that it's up to date and it does not execute the recipe. In this case, that's not the intended behavior. We want Make to print out hello every time you type make hello. So what we have to do is we have to mark the hello target as a phony target. A phony target is a target that does not produce a file as the output. Whenever Make tries to build a phony target, it will always execute the recipe. The way we can define a phony target is by typing .phony :hello. Every target you mark as phony will always be run anytime you type make and the target name. So if I save this and quit and run make hello again, you'll see that it prints out hello. And if I try again, it'll still print hello. And if I remove the hello file and run make hello, it'll still print hello. So marking a target as phony ensures that it will always be rebuilt by Make. Okay, now let's get into using Make to actually build C code. Building C programs is often divided up into several steps. First, we often compile source code files into something called object files that end in a .o extension. Whereas your source files contain regular human-readable source code and typically end in a .c extension, the object files are not human-readable, they're binary. Once we have built several object files, you can link all the object files together to produce an executable, and this is something your computer can directly run. So the two steps that we'll be talking about in this tutorial are building object files and linking them together to produce an executable. You can feel free to read more about this on the internet, but it doesn't really matter. All that matters is that you build the object file first, and then link together a bunch of object files to build an executable. So let's see how that works. I'll go back into my Makefile, and notice that in Calculator I have two files, calc.c and calc.h. The calc.c file is just a source code file, and calc.h is a header file. Similarly, in utils, I have a utils.c and utils.h. I want to produce an executable called app at the end that takes in the source code from app.c, combines it with the source code in utils and calculator, and produces an executable my computer can run. So let's build each component by itself. Again, the first step is to build the object files that end in a .o extension, so let's do that now. First, I want to create a .o file for the calculator. So let's create a target called calculator/calc.o, and I'm calling it this because this is the file that will actually output in the end. So I want to tell Make, hey, when you run this rule, expect this file to be built. Each target also has a set of prerequisites that you list on the same line as the name of the target. In this case, the calc.o object file will depend on calculator /calc.c and calculator/calc.h. This tells Make that anytime one of calc.c or calc.h changes, it needs to rebuild the calc.o file. However, Make is intelligent in that if something in utils changes, it will realize that it does not need to rebuild the calc.o object file. If you're working in large code bases, this can save a lot of time. So now what we'll do is we'll type the recipe for the target calc.o, which just specifies how Make should build the calc.o file. In this case, it's pretty simple. We'll just type gcc-c calculator calc.c, and let's first cd into the correct directory, so it's cd calculator, and run this. So this just says cd into the calculator directory, then compile calc.c using gcc. Excellent. Now let's save this and quit, and run make calculator/calc.o, and you can see it's compiling. And now that it's done, if I ls into the calculator, you'll see that there's a new file called calc.o generated. Let's also do the same thing for utils. I can do utils/utils.o. Again, the prerequisites for this rule are utils/utils.c and utils/utils.h. Then again, we'll cd into utils and gcc-c utils.c. And now this should generate the utils.o object file. Now the last object file we want to generate is for the app. So we'll compile app.c into app.o. So the target will be app.o. It depends only on app.c. And the rule for this file is just gcc-c app.c. Excellent. Now we have all the object files we need, and we want to actually combine the object files into an executable. That is, we want to link them all together. So to do that, I can specify the name of the output file. In this case, I want to call the output executable file simply app. So I'll say the target is app, and it depends on all the object files. So it depends on calculator/calc.o. It depends on utils/utils.o, and it depends on app.o. Excellent. And then the rule this time is just gcc-o app. A -o flag tells GCC where to put the output. And then we tell it what files to link together. In this case, that's calculator/calc.o, utils/utils.o, and app.o. Since app is the main goal of my Makefile, I want to build the app executable. I want app to be the default rule. Now, one way I could make app the default rule is by moving it up to the top of the Makefile, by copying and pasting the rule and putting it up here. I can also define just another rule that you'll see often called, let's say, all, and I'll list app as a prerequisite. So now if I type make all, make will say, oh, all depends on app, and so it'll execute the rule for app. Since all is the first target, it'll also be the default target. So if I simply type make, it'll realize it has to go make all. Since all doesn't generate a file, I will also mark it as a phony target. So let's add it to the list of phony targets by typing all up here. There we go. And now if I save and quit and run make, you'll see it's printing out the steps that it performs. And then if I ls, you'll see there's an executable called app. And if I run app, it prints out the expected values. Now let's go over a few more things that we might want to do with a Makefile. So I'll open up the Makefile again. Typically, you also want to be able to remove all these generated files if you, for example, want to compile from scratch. So let's add another phony target called clean that will clean up all of the files in our project. So we'll define the clean rule. We'll say it doesn't have any prerequisites, and this will simply remove all of the generated files. In this case, that's calculator/calc.o. We'll also remove utils/utils, make.o, and we'll remove app.o, and also the app executable. So if I save this and quit and type make clean, it'll remove everything, and I can see those files are deleted. And if I want to make the app again, I can type make or make all, and then the app will be regenerated. Excellent. So let's also cover a few more tricks. You can see in this rule for building the app, I kind of had to type the list of dependencies twice. Once here, and then once to actually compile them. I can kind of simplify this using a trick in Make, in that Make has special variables that give you useful information. So in this case, I want to be able to put all the prerequisites for this target into the compiler. The way I can do that is by typing dollar and a caret symbol. This is a special make variable that says insert all the prerequisites for the current rule here. So now what this will do is when we run make app, it'll simply replace this dollar caret with calculator/calc.o, util/utils.o, and app.o, and so it should produce the same result as if we had typed them out manually. So let's save this and quit. Let's make clean, make app, and /app, and you can see everything is the same as it was before. Another nice thing about Make is that you can kind of define a hierarchy of Makefiles and reference them all in a root file. This way, if your root Makefile becomes too big, you can split your project up into subdirectories, with each one having its own Makefile. And then you can have one root Makefile that ties all of them together. Let's see how that would work for this very simple example. Again, you might not want to do this for such a small example, but it could be helpful if you have large projects. So let me quit out of this file, and let me go into Calculator, and let's make a new Makefile here. In this Makefile, I will just build the calc.o object file. Since I'm already in the calculator directory, I don't need to call this calculator/calc.o. I'll just call it calc.o. And the prerequisites are again calc.c and calc.h. And the way I build this rule is by doing gcc-c calc.c. Now let me save this and quit, and if I type make calc.o, or if I type make, you'll see calc.o is already up to date because make notices that the source files have not changed. Now let's remove calc.o, and if I run make calc.o, you'll see it rebuilds the calc.o file. Okay, now let's use this new Makefile and reference it in our previous one. So in our root Makefile, we'll go back here, and we'll change the rule for calculator/calc.o. And for the recipe, I want to use the Makefile that was in the subdirectory. The way I can do that is by typing make-c calculator calc.o. This just says run make, switch into the calculator directory, and build the calc.o target in that directory. So we switch into our calculator directory and run the calc.o target that we defined in our new Makefile. Again, if I try running make app again, you'll see it recompiles a few things, but other than that, it's working fine. And if I do /app, it still works. The last thing I want to cover briefly, even though it's a big subject on its own, is variables in Make. In Make, you can define your own variables that help you to save repetition in typing. We already saw one example with the $caret special variable in Make, but you can define your own variables as well. In this case, let's say I want to be able to easily switch out which compiler I use to compile my files. I can do that by typing a variable. Let's call this variable cc, short for C compiler, and let's set it equal to GCC. And now I can, instead of typing GCC, I can change this to say $cc in parentheses. This says just expand the value of cc and put that here. So now, since I define cc to be GCC up there, Make will replace cc with GCC and run it the command as it was before. So let's do that here too, and that should be it. We could also do this for the Makefile in the calculator directory, but I won't do that for now. Now, let's say I want to define a new variable called cflags that stores the flags I want to pass to the C compiler. GCC provides several options you can pass it. For example, turning on warnings and enabling compiler optimizations that speed up your code. Let's try that now. So I can define a new variable, let's say cflags, and I can set it equal to -w all, this says turn on all warnings, and -o3, this says turn on optimization level 3, so the compiler will try to optimize your files. And now, in each of the compilation steps, I can type cc and put in the cflags as well. And so this will pass the cflags to the C compiler. There's nothing magic going on about how these arguments are passed. Make is just expanding cc to GCC and putting that here. Then it's expanding cflags to -w all -o3, and it's putting -c app.c. And we can do the same thing here. Passing the cflags, and let's save and quit. Let's run make clean to force make to recompile, and then let's run make. And you can see how make did the substitution. It expanded CC to GCC and C flags to -W all -O. So hopefully this introduced you to how Make can be used with C projects. Of course, there are so many more things that you can do with Make, and it's quite interesting to learn how it works. You could also use Make to trigger the protocol buffer compiler to generate the protocol buffer compiled outputs. Or you could use it to format your files, for example, by defining a phony target called format that runs some code formatter of your choice. There are so many possibilities, and there are so many other build systems that you can use in addition to Make. And so I hope this video inspires you to learn about some of those on your own. Alright, thanks for watching. See you next time.